I would like to introduce Grattafiori and Josh Yavor for the Hacking Samsung TV.
Good morning, everybody. So before I start, can I see can you guys raise your hands if you own a smart TV? Just any brand. Okay, that's quite a few people. And then how many people own a Samsung smart TV? That's quite a few as well. Great. So does anybody kind of in the front here know what's happening in this famous scene? Exactly. He is putting on a great 50s sci-fi show called The Outer Limits. How about this one? Movie? Right. So the basic idea behind this talk is that we didn't know too much about smart TV security. We know a lot about mobile application security. We know a lot about laptops. We know a lot about computers and servers and networks and all those kinds of things. But really, we wanted to see, can we take over somebody's TV remotely? Can we control the horizontal and the vertical? Can we, use the camera and the mic and other things like that? So, the outer limits. So I'm Aaron Grattafiori. I work at ISEC Partners. This is Josh Yavor. Big thanks for BlackHat for accepting our talk. Big thanks to everybody at ISEC. And again, Samsung for working with us on issues. So we performed this research in December of 2012. And we reported all these issues responsibly to Samsung in January of this year. Through some kind of timely fixes, we were cleared for disclosure in June. And they have been adding more and more security, and the 2013-2014 models have a much more robust security model overall and better architecture. So a little background. We know a lot about smartphones, right? You can see the iOS development line there on the bottom. And really everybody has a smartphone these days. And there's smart watches that are coming out, smart cars, smart fridges that have Wi-Fi. There are smart windows and smart houses, really. And the byline for this movie that came out in the early 2000s is pretty funny. When a computer at home has opinions all her own. So I say, challenge accepted. And even smart toilets. So this came up in a press conference yesterday, and I had to rush and throw this slide in just because I think it's utterly ridiculous. Yes, the toilet has Bluetooth. So, but we're here to learn about smart TVs, right? So when we talk about smart TVs, we're not talking about a Boxy or a Google TV or a Roku or any of those things. We're really talking about TVs that have the smarts inside. And smart TVs have been becoming a lot more popular. You can see that maybe 3/4 of this room has a smart TV of some brand or another. And there was almost 70 million sold in 2012, and that's projected to be almost 100 million this year. Now, that's worldwide sales. And market penetration, even among non-techie people other than this room, is really getting up there. And so this is in a lot of homes, and so it's something that we need to learn about security of. And really, it's not Samsung we're trying to pick on here. There are lots of different vendors. This is if you look at Best Buy and you go and try to buy a smart TV, they've got this huge list here. And so you can see that not only does Samsung have the most models, but really they have the most features and the most apps. And every time I say App Store, Apple gets a quarter. But essentially, those applications are attack surfaces. And so we really wanted to look at, remotely, what can you do? Locally, the TV has lots of other attack surfaces, and we're going to talk more about that. So we started off just thinking about how does this compare to a smartphone? We know all about mobile security. And, both smartphones and smart TVs, at least most models, have a front-facing camera. They both have apps, thousands of apps flying from cyberspace or some kind of thing like marketing images show. They both have browsers, so that's a good attack surface. They both have social media applications. And that's even more attack surface, and maybe things are exposed to people that you have less control over. And they both have this great free backup service that happens whenever you visit sites or download anything. So really, comparing it to a phone is difficult because while it's very similar in some respects, there isn't too much research out there into smart TVs. And what is the Linux how is the OS built, and how do the apps work? So there has been some past research. There's been some past disclosures for related to other TV manufacturers, but really there hasn't been too much that's very in depth. And you can see some other manufacturers there. And as far as on-stage presentations, there's another presentation today by Beist, who is speaking about surveilling people using their own TV. And it touches on some very similar things to our talk, and I highly recommend going and seeing it because there are some very cool demos and he has done some very solid research. As far as advisories go, there hasn't been too many. So speaking specifically to Samsung, in April, Luigi came out with a bug related to a MAC address. So the TV local network, the way when you do use the remote from your phone, it uses Wi-Fi. And it uses a kind of custom binary protocol. And essentially, the authentication is done via the MAC address, because MAC addresses can't be spoofed. But you send your MAC address and the TV has some message that pops up. So essentially, he was able to find that with an invalidly formatted MAC address, you could crash the TV and it would actually enter an infinite loop. Because what would happen is it would save that, do you want to accept this device out before it displayed it. And so what would happen is every time the TV booted, it would go and launch that and then crash and ad infinitum. There in June of last year, there was another issue related to UPnP. And obviously UPnP has gotten a lot of play after that, but that was a good find. And then December last year, actually the week before we started our research, there was a video that came out that said TVs can watch you and we have these attacks remotely via the network and some other things, but it was only 30 seconds long. It was only on the 2011 model, and there was no other info. They didn't release any advisories. They didn't work with the vendor at all. It was just kind of a black hole of showing people what they could do. But it was cool. So our vulnerabilities, we reported about 15 different issues. We worked primarily on 2 different 2012 models. And these vulnerabilities likely affected the prior years and may have affected the future years had we not reported them and found them. And we're not discussing every single problem here, but only kind of the high level ones and the ones we think are really worth discussing and showing. So let's kind of, let's get our heads in the game here. So under the hood, this is going to look very familiar to a smartphone. In some ways, it's really just a smartphone with a 50-inch screen, as from a hardware perspective. It has, a gig of RAM, a gig processor. It's ARM-based. There's a microphone. There's an HD front-facing camera. There's USB ports and all that kind of stuff. And then software-wise, it's also Unix-based. It has an app store. There's a browser. There's web apps. There's, social media applications. There's an SDK and a development community and on and so on and so forth. But really what we're talking about when we're saying all these smart things that it can do in the hardware and the software is really attack surfaces. So remote is the attack surface that we thought we should focus on that. Because a local attack against somebody's living room, not super realistic, not quite as snazzy, and obviously not quite as scary. So obviously there's a bunch of different attacks remotely that we can do using all kinds of different protocols. We intended to look at lots of different things, and we kind of stopped at the first 2 bullets because we found too much. As far as local attack surfaces, after you've already gone on to the TV, or you've got an application that's on the TV, or you've got a shell on the TV, there's a number of different attacks you can do to attack the thing locally versus remotely. So we had all this kind of ideas on what we're going to do things, but we didn't actually have a TV. We're actually moving offices as this was happening and kind of coming up with some of this material. And so we started with the easiest thing, documentation. Let's go to the website, let's see what it says about security, Let's see what other people have said online about this exact TV or applications or that kind of thing. The other way that we did it, kind of working smartly, was just download the firmware. I'll just look at things that way. I don't even need a TV. I can just start the analysis with both documentation and in firmware. So the documentation on the Samsung site is quite good in some ways. In some ways, it's excellent because it documents things that you're not actually even supposed to be able to use. So if you look here, it says security type system and remarks restricted by use by a widget manager only. That's interesting. Maybe we should try this. And one other thing that I'd like to note here, if anybody that works on the Samsung site is here, can you please make it so that things be open in tabs? There's a forum where you can look at what all different developers have been doing, and if you try to open something in a new tab, like we all do, you have 50,000 tabs open, it doesn't open. They use a JavaScript call, and it's silly. And so, looking around their site for security, there is this single page with approximately 50 words that says, basically, if you see this pop-up when you're trying to install an application, maybe you should visit this web page. And I'll show you exactly what it says there and a little bit more about that later. But really, it doesn't talk about permissions at all. It doesn't really say much about how you go about accessing the camera or accessing the file system API. And so, we can find some other things by looking around. We see that, this is developers calling this out. So they noticed that, as early as 2011, that, any app in the TV or the TV in any way would just accept any SSL certificate or connection. And that there's a notion in the documentation of secure storage. So obviously we look at that. And we find that, that there's another developer that says, hey, in order to use this secure storage, you're supposed to prefix any file read and write with your app ID, which is just a number. And so what happens is the developer's like, hey, I could just put in another app ID and I can read their files. How is this really secure storage? And then there's no other comments. And really, there's no mention about security much at all. And we see some more documentation gems. We see that, in order to use that mobile application, in order to control your app, in order to use your TV from your mobile phone, it uses SSL. So, we're going to look at that. Obviously, that's usually a pain point. And how do they do the certificates? Well, they say that in order to actually use SSL properly, you need to go and request a CA from Samsung and install that into your phone. And, I know my mom is totally going to do that with her TV. And the other thing is, we see some very scary sounding things. Executable process, downloading the EMP server, and executed by the TV JavaScript. And there's a lot of pieces there that, when those are put together, it sounds, ugh. And as far as non-Samsung documentation goes, I have to give a huge, huge shout out to the SamiGo rooting community. So it started as essentially a jailbreaking website, and it grew and grew and grew. And a lot of the initial work, some of the hard work of looking at some of the basic stuff, they did a very good job of documenting and talking about. And really, it saved us a ton of time getting started and extending a lot of the stuff that they initially worked on. So huge shout out. So let's look a little bit more about how this thing works. So, we can decrypt the firmware. The firmware is actually encrypted, and then inside of that, it's XORed. But obviously, they spent a lot of time with some hardware attacks, and were able to get the key out and then publish that. So that saved us a ton of time in decrypting that firmware and doing the XOR, which I don't know why that they do AES and XOR. And when we start looking at the firmware, it's really actually just a little piece. There's a bunch of other stuff that gets downloaded after the firmware image is written. So we kind of only had this little window. And, but we can see things that are, might give us hints about other stuff after we get our TV and after we, get Telnet on there and start looking around. And we see that, there's 19 different partitions and that there's kind of libraries and shell scripts and binaries and non-strip binaries and non-strip libraries and strip libraries kind of scattered all around. So it's quite chaotic. And we also see, these encrypted CMK files, .js.cmk, .xml.cmk. And so, that looks interesting. Maybe we should look at that. And there's also EXP DSP. And that's kind of the god of the TV. It is a 116 megabyte binary. So, hopefully throwing this in IDA, you've got a lot of RAM. It runs all the different services that the TV runs via the network. It runs a web server. It runs all kind of things. Runs as root. So that's interesting. And we can see lots of other stuff. We can see that the TV actually uses X11. We can see that it has a local Lite web server, that we've got some WebKit in there. That doesn't have any bugs. We have RC local, and we've got shell scripts, and it's Unix. I know this. And what it really comes down to is there's kind of three main partitions that are key. There's where the firmware gets written, which is mtd.exe. There's a writable directory called mtd.rw common, and that's where the widgets live. Common directory lives for common storage. There's temp download. There's a bunch of other things. And there's this other RW area, which is also obviously writable. And things like, your DNS settings and some other possibly important stuff are in there. And, we can see that really this is kind of coming to be a Linux box. It's that V4L, Video for Linux, that's super common, right? And they're just loading some modules and exposing Video 0 device. Okay. And so those CMK files, we kept kind of going back to that. There was thousands of them. And we see this manager, and it's under the InfoLink folder, which is what the Smart TV used to be called way back when. So we're like, okay, well, I want to undo that encryption, right? I mean, you can't, your mom says you can't go out tonight, you go out. So if we start looking around a little bit more, we can see this CMK to SCK. And I don't know what the SCK is, but I know I want it to be something else than what the CMK is. So if we find, using just strings because we're lazy and busy, we can find a reference to that in libsecurity plugin .so. So not strip, that helps, but really we don't need too much other than hex dump and some time. So if you look around for a while, you can find the key in the binary as well as the IV, and you just decrypt things. So you can decrypt all those CMK files. So that's awesome. But really, we want to work smart, right? We're busy. We're trying to fit this into our few weeks that we can while we're busy with other projects at ISEC. But there's this new emulator that came out in spring, and so actually after we had done the research a few months ago, I looked at that. Well, so it doesn't have any encrypted code, but it does have all the CMK files. That's a win. And it has unstripped x86 versions of all the IPI libraries and all kinds of other libraries. So that's also makes our lives much better because ARM is painful. So other than, the install base and how, some of the APIs are, what does this thing look from the network perspective? So it has 8 open ports. It doesn't really have a firewall. The binary, the exe DSP binary, which is that huge thing, is running all of those as root. And a bunch of them don't require authentication, some of them do. But really, we started looking at those, and then we said, okay, wait, let's back up. Let's look at apps. And that's Josh.
All right, so application development on the Samsung Smart TV, as we got started, was really painful. There was a steep learning curve. As Aaron mentioned earlier, the current development VM was not available to us, and just trying to learn the development process was pretty challenging. It's gotten a lot better since then, so if you want to dive in and start taking a look at this, it's much easier now, and those virtual machines are great for doing that. The application structure is actually really basic. You see the 4 core components of any application up on the screen. The The overall process that we had to go through was a lot more complicated because we were, first of all, trying to not design real apps, we were trying to design bad and malicious apps. So that made things pretty difficult for us because the debugging and error reporting on the platform is lacking. So let's take a look at what these files actually are. So config.xml just defines all these different options for each one of the applications. So some of these are really self-explanatory as far as the name, the author, but there are a lot of other undocumented options that will show up in these config.xmls. Some of those are pretty interesting, like a security, yes or no. We're still not quite sure 100% what that means, but it sounded like an interesting option, so we turned it off. There are also things that allow you to block forced updates within an application, and that came in handy later as well. One thing that you might notice looking at this example configuration is that while this is for the Skype application, the author might stand out to you. And that's because the author is not Skype and Microsoft, it's actually Samsung. One of the things that we found in looking through a lot of the brand name applications that come with the smart TV is that it appears that those partners that work with Samsung will provide binaries and libraries to Samsung, and it's actually Samsung that develops the application and does the integration on the TV. And that's something that worked to our benefit because we're actually able to find some common practices between those applications and really get a feel for how those were developed in the first place. The index.html file is also present in all of the applications that run on the smart TV. So this is what is actually loaded by the Smart Hub, which is the name of the smart TV operating system. And so it just loads this index file, and within the index.html file, it pulls down JavaScript and it creates JavaScript objects. So by looking through all the index files for many different applications, we're able to get a lot of information about how each one of those applications interacted with the TV. We were actually able to look at all of the applications that come with the TV and find different code and APIs that were undocumented, at least at the time that we were looking at the Samsung development forums. So that was a great source of information as far as identifying things that we weren't supposed to be able to identify, use, or even know about. And the JavaScript is really what is the core of the application. It does all the heavy lifting. It is important to note here that the application development choices that developers have aren't limited just to JavaScript and HTML. You can also use Flash, and you can also use if you partner with them, you can provide native binaries. In the past, they had some other development options, but these are the three that are available now. Most applications, by and large, are developed as HTML and JavaScript. So in the slide that we have up right now, you actually see a sample JavaScript function that comes out of the Skype application. So here we have the plugin API manager get my storage info function. And what's interesting here is that, well, there are two things. First, that the function actually is calling another function that executes read widget data on Skype info, which stood out to us because that's a lower level function that we could perhaps use to get information out of other applications that might not actually use that get my storage info. Another thing that might stand out is the fact that there's a JavaScript alert here. And that's kind of odd because in a traditional web application, that would pop up a JavaScript alert box in a browser, for example. But in the smart TV, what alerts are actually used for is logging. And that's something that was pretty interesting for us to find because that showed us how much they had modified WebKit so that they could actually customize this platform. So looking at the core components of the applications and figuring out how they were built, it dawned upon us that we're just looking at web apps on a TV. And we know web apps. We definitely know web apps. We work with them all the time. So these web apps need to actually interact with the operating system and the hardware of the smart TV. And so that's the next question is, so we have these applications. They're basically just web applications that are being shown on a web server on the TV. But how do we actually get those applications to interact with the fun stuff, like the camera, like the microphone? And that's where the API interactions come into play. And Aaron's going to take it from there.
Great. So, yeah, we were thinking, this is web apps. I know this. So, we started looking at the APIs because obviously, a web application that doesn't do very much, or a TV widget that doesn't, just display some things on the screen isn't super interesting. You want to be able to use the network. You want to be able to play video. You want to be able to read and write local storage, things like that. So, we see this documentation that says, Ceph plugin provides calling native C++ middleware from JavaScript. And that definitely makes us scared. You can get file system access. That also sounds very interesting. And, really there's more features with the web API. So we're like, wait, device API, Ceph plugin, web API. There's a lot of APIs. So just looking at the device API, not the Ceph API and not the web API, we get, camera, audio, external widget interface, file system, front panel, IME, all kinds of different things. But there's more. There's a player, there's a network, there's time, there's TV, there's a video, there's window. There's all kinds of things. And every one of these is backed by a C++ object. So, we know that developers don't write bugs very often. So clearly, we needed to exercise some of these things. So the TV has a developer mode you can put it in, where you log in as the user developed with a 6-digit 000 password, or I think maybe even any password. And that lets you, the TV gives you an extra option in the settings, where it essentially just downloads a configuration file that's defined in XML and pulls in a user widget. And then lets you open it and test it on the TV. Users need to be able to test things live on a real TV. So we thought, okay, let's put Telnet in our widget, and then we'll put it in the TV and we'll see what happens. So we just threw an ELF binary in there, and we see this message when you try to install. Failed. For more information, visit that one security page we have. So if you look close at what that says is, you can't, we've got some security modules that prevent you from, hacking the inner TV system to get user keys, user data, so on. So how does that work, right? We've got the code. We can look around at things. So there's the engine. And if you look closely, you'll see some interesting function calls there. Scan source. Document API checker main, start analysis. And you see some other stuff. Analysis ELF binary. So clearly they know something about, not allowing people to include ELF binaries. And, they're searching for undocumented APIs being used. So, how are we going to get past that? I mean, JavaScript, that can't modify itself or be obfuscated in any way or load things dynamically. That's hard. So, we've talked a lot about how the applications are fit together, how the APIs kind of work at a basic level, a little bit about the OS, but really, we're here for attacks. So, going back to our developer install, we really got caught red-handed. And we didn't, we wanted to include that ELF binary, and so, we can get a shell on TV, right? That makes everything, that makes our lives much easier. So we thought, okay, well, there's a zip function. What if we just zip the ELF and then put that in there, and it worked. So, yeah. So kind of just to recap, we've got our ELF binary, and we can put it in a zip file, and we can dynamically load the file system API after our application runs. So our index.html actually doesn't really have anything at all. It just calls JavaScript. And then in JavaScript, what we do is we just load the file system API dynamically. And we could obfuscate it if we wanted to, but we don't actually need to. But really, we can load that. We can copy our zip around, and we can unzip. But now we have two problems. One, our binary isn't executable. And two, well, we haven't figured out a way to run it. So, we load the file system API, and that gives us, copy, unzip, isExisted path, some other functions that you can pull out from reversing. So how do we actually run our Telnet D? So, we've got the APIs, and there's all the different kinds of APIs. And, there's definitely going to be some design problems there and some business logic bypasses. But, maybe those APIs themselves are going to have bugs, not just in the use of the APIs. So, we said, okay, well, let's do some proc tricks here, right? We've got Linux. Let's copy command line onto a thumb drive, which is that DTV USB SDA one. And let's see what that says. So we see at the very beginning of it, bin CP. It's like, bing. And we're thinking, that's not good. So then we tried some other things, and finally we landed on this one. $reboot in the second argument, or $anything else. So we throw that in there and we run our app, and the screen turns off. And then we dance. So, we've got the file system API. It's got some, arbitrary command execution. But are there some other bugs in the other APIs? Let's keep looking. So there's the download API. And the download API has an upload function. I don't know why the upload is in the download, but it doesn't matter. So we have a video here, and I'm just going to pause it here real quick. And essentially, you can see my laptop's screen, and we don't have the video of the actual screen because we left that on the wrong camera. But you can trust me that we're loading an application in the background. And you can kind of see some of that activity. But essentially on the left side, you can see that we're serving a web server there. And on the right side, you can see that there's a post server. So it's just accepting HTTP posts. So I'm going to go ahead and play this. And you can see some activity in the background on the screen there. And in a second, what you'll see on the left side is there'll be a request. And that's going to be a request for JavaScript. And I'm sorry if you can't actually read what it says, but you'll see something happen there. And that request right there will call the upload. And see, on the right side, you saw those things scrolling. That's the TV uploading files via the download API. And those files are lots of different things. So how does that actually work? So what we do is we dynamically create our download object, and we open it, which is kind of the format of how you use some of the APIs. Then what we do is we just specify, well, I want to upload the common widget manager info.xml. And what that file is it is your currently logged in username and password in plain text, along with all the widgets, which are really the applications you have installed on your TV. And then just for kicks, we upload a kernel log, which has some interesting stuff in there that may or may not want to be logged. And really, what this means is we can specify any file that's readable, and it will be uploaded. Any file on TV can be uploaded. So your Wi-Fi password for your local network, your Bluetooth pin, if we wanted to get so fancy, any other storage you've saved. So if you've got pictures on your TV, if your TV is plugged into an external hard drive, we can get those files as well. So I'm not going to try to make this sound, but if you watch the movie Inception, there is a very, very famous sound, and I'm not going to embarrass myself by audibly saying it, but suffice it to say it's very well known. So if we go back and think about the widgets, we've got user, and that's when we have our in development mode. We've got normal, and that's for normal kind of everyday applications, normal apps you install, Netflix, things like that. And then there's manager in there too. And note, this is the RW common directory, so it's writable. So manager, So we look in there and we see, very interesting sounding things. Controllers, EMP, main models, MVC, settings, smart home, all kinds of stuff that's like, oh wow, that's a lot of stuff. And we see those darn CM key files again. So we decrypt all those. And we start looking through those files. And smart home main.js, that's got a lot of stuff in it. That's there's sync manager, there's account controller, there's login. So this is kind of like, whoa, wait. So this is JavaScript, and this is loading the JavaScript app. So we've got JavaScript and JavaScript. So what that means really is that this whole thing, when you're looking at the Smart Hub here, that whole thing is a web application. those boxes, your menu when you move your mouse around, that's all divs. Yeah, and a lot of those files are encrypted and decrypted at runtime. So that might be a performance hit. So, we've got the local attacks, and we can do lots of the bad things with, malicious applications that may become, maybe published through the App Store. There's not too much information about the, review that the apps go through or any of that stuff. But really, we want remote attacks. So I'll let Josh talk about this.
So social applications by default require remote connectivity, and while at the same time being an application that is installed on the TV. So in the Samsung Smart TV, the applications that we're talking about are the ones are the usual suspects, really. So it comes preloaded with a Smart TV exclusive application called Family Story, which we actually didn't look at as part of this research. But also Facebook, Google, Skype, all the usual suspects. There are also countless applications that are developed by third parties that integrate with other social media networks that will also be available on the Smart TV. So social media applications really are just remote content injection. So what we wanted to figure out is, can we take that remote content injection and make it remote command injection? So one of the things that I'm sure we're all aware of is that none of our friends ever have their social media accounts hacked. Especially like that aunt whose password was password and is now sharing all those malicious links with you. So we took that example in our mind and said, okay, well, what would happen if we were able to do that to a smart TV? Actually get malicious content in a status update, in a chat session, in a message to a user who is actually using one of the social network applications on the smart TV platform. What can we actually do there? Knowing that it's actually written as a web application and that JavaScript is at the core of that application, what if my status message was alert, hey, what's up? Would we actually be able to get that to execute as JavaScript in the context of that application? We'll get back to that. So with the Smart TV platform, one current drawback that it will probably improve in the coming months and years is the fact that entering text is still challenging. You need to have a keyboard, and typing into it, because you have JavaScript within JavaScript, it can be a little bit laggy at some times. So like actually having a full-on chat conversation with somebody isn't really that comfortable. It's not like what you can do with a standard desktop operating system, or even what you can do with text prediction on your phone. So what we wanted to look at were the social media applications that people that own smart TVs are most likely to use. And that requires video communication and microphone communication. We stayed away from the microphone communication because of wiretapping laws, if we ever did actually want to play with this. So we just stuck with video. Speaking of video, the TV platform is actually really, really attractive. If you think about it, unlike a cell phone where you're trying to hold it up when you're trying to have like a Skype conversation or FaceTime or something like that, and you're moving around, it's really hard to keep your shots still. It's hard to do framing properly. But if you actually have a smart TV mounted to your wall or sitting on some piece of furniture, and it has a camera attached, a nice big screen, it's hooked up to your nice sound system, it's a really great platform to talk to family or do any type of other video chatting. So with that in mind, we had to figure out, okay, which applications actually use video? What's going to be the best target? Skype. Tons of people use it. The application is easily available within the App Store that Samsung provides. One thing that's important to note here, like I mentioned earlier, is that what we're going to talk about now is not an issue with Skype itself. It's an issue with how the content coming from Skype was displayed on the smart TV, and that was not actually developed as part of Skype. So this is an issue with how it was just simply being displayed. So Skype has all the things we just talked about: video access, chat, messages, automatic sign-in capability, and that was really important too. So the slide says it all. Skype was a mess as far as a social media application on the smart TV. There was injection vulnerabilities throughout just almost any type of field that we were able to come across. Locally, anything that could be entered by the user using the keyboard, you can inject JavaScript into, or HTML even, and that would actually be executed in the context of that application. Remotely, mood messages and also the chat had the message content executed as code. So obviously that gives us access to the Skype account. as well as the API that was provided by Skype that is then implemented by Samsung on the smart TV. So we could do anything as any Skype user once we were actually able to get into that application. So here's an example on the screen that you can see of the local injection. This is just with a keyboard. We're actually able to enter an image tag into the name of our user that we're or our contact that we're trying to add, and it actually renders as a failed to load image right there. Remotely, it gets a lot more fun, because with what is documented as a mood message or a status message on Skype, we can remotely inject code. And this is another just benign attack that you can see right here, where there's another failed to load image in the middle of the status update for that user. So that's a update that was controlled by a remote user, thousands of miles away potentially, that now is being injected onto our platform. So what can we do with that? You saw the reboot command that Aaron talked about earlier. So what we did was we actually just injected a JavaScript download into our mood message that executed that reboot. So you could have a chat with somebody, you could update your status, and magically everyone that was on Skype that was a contact of yours would reboot if they were on a smart TV. That's pretty tame. So let's talk about something a little bit more devastating. Credential theft. So one of the things that remote code injection allowed us to do was actually run that get my storage info call that we talked about earlier. What that actually returns is not only the expected storage info, which is the path to the Skype storage, but it also included your Skype credentials, so your username and your password. So using the attack that we have up on the screen now, we're actually able to retrieve the credentials. Now, getting that type of information is great, but we actually want to lay down roots and actually persist on the device. So we need an application that would actually automatically start every time the TV also started. And Skype was perfect for that too, because we're actually able to set it to log in anytime we turn on the TV. So what that meant was that if we were actually able to modify the executables that were loaded at the time that the TV was started, then those would be executed with our code anytime the TV started. And so that's how we could actually have a persistent rootkit through Skype on the smart TV platform. And that's something that is, with the code injection issue, is difficult to fix, because if Skype needs to be updated, you have to keep those binaries in a read-write location. So bottom line is that we've demonstrated that on the applications we can achieve remote compromise, especially through social media application, any place where we can get remote content injected. We can install a rootkit and actually have full system control anytime that you boot up. And because it's a social media platform, we can distribute our code to other smart TV users now, which means that we have really created a TV worm potentially at this point. And using those social media venues, we can also use that as a command and control stream as well. And with that, we're going to turn it over to Aaron, because one of the things that we are still lacking at this point is we've got remote injection onto a application, but now how can we actually do that without actually dealing with a standard application on the TV? What if the user didn't install it?
So I don't use Skype, but I do use browsers. So, again, we started looking at the widgets that are on the TV, and we noticed that widgets normal, okay, WebKit UI. Okay, I see WebKit, and that makes sense when I read browser, but WebKit UI? So if we look in there, you see some interesting stuff. Content pages, config, index.html, that seems familiar. Controls, components, browser.js. So if the browser is just like the other apps, does it have the same problems? Let's find out. So we started some different attacks. We thought, okay, when you view you can view different windows in the browser, and the title of the page that you're visited is in the Windows display, and you can have multiple windows. And so we said, okay, let's put title in, some XSS in a title and see if that works. And it didn't. Shoot. Okay, let's try navigating to iframe. and we see this. And if you look closely, there's a little line right there in about the middle, right there. And what that is part of the iframe box that's loaded in the navigation bar. Okay. So that's cool, but nobody's actually going to go out and try to navigate to script, include, from some remote source. Nobody's going to do that. And so, okay, let's think about some other attacks. Maybe we could do, we can load our page, and then we'll do like document.location script something, and maybe it'll update that dynamically or something. Who knows what they changed? And that didn't work. And then we thought, okay, well, maybe we'll do window.open iframe. And then, shit, that didn't work either because it checks that there's that's not a valid domain. And so then we thought, okay, well, I'll just put some stuff at the end of a URL and I'll open that as a new window. And then it got encoded. Ugh. So then we're like, what are we going to do? And then we thought, okay, well, there's this fragment thing. And that lets you specify things at the end of a URL that don't have to be URL encoded. So then we tried window open, test, hashtag, iframe. And it works. So we can now dynamically include JavaScript and it runs. So then we, rather than just having iframe, that's again not too interesting. We want to, make stuff happen. So then we started, putting a whole bunch of stuff at the end of the URL in a fragment and putting, script and trying to unescape and do all that kind of normal stuff. And it's not working, and it's not working, and there's no debug environment, obviously, because it's not really supposed to happen like this. So then we're like, okay, let's just throw that in an alert, and we'll see what gets decoded as after our URL decode, and we can get some debugging. So then we see this, and if you look, that's an alert box, but there's an image inside it, and that's because the alert box is just wrapped in JavaScript. And there's an injection in the alert. So then we can do something like this, where we have our big blob of escaped code, and then we just we do an alert, and we do our little XSS. So we do cross-site scripting, not of the web app the browser is loading, but of the browser itself. So now that we get kind of control and we're running JavaScript as the browser, we can do some interesting stuff. We can change your homepage to be our attacker site, so that before you even do anything at all, when you load the next time that you load the browser, it hooks our app or it hooks our code, and we can start doing whatever we want at that point. So that's a cheap persistence trick. And just for the hell of it, we turn off privacy mode because maybe we want to upload your web history later. And then we close the browser. So let's look at how we can do something even cooler. And so this part is the only tricky thing. So this video in the top, I have to start slightly earlier. And you'll see there that it says DNS server 8.8.8.8. And that's the valid DNS server. So I'm going to let that one run a little bit. I'm going to stop it, and I'm going to start the other one. And these are both filmed with two separate cameras, so I'm going to kind of let this one catch up in a second. Okay, so they might be slightly off. They are more than slightly off. But what's happening in the top one, well, let's pause that one for a second, is that we popped up an alert, we got code execution as the browser, and then we changed the DNS server to be a local server that is in the bottom image. So then we're going to keep going there. And the timing is slightly off. But we're going to reload that blackhat.com. So HTTPS, keep a note, blackhat.com. Huh. That's weird. MI5. That wasn't blackhat.com. So there's kind of two things here. One is that SSL is just that little lock showing up. And that's about all the validation that's being performed. Oops, let me pause this. Let me pause this is the right place. Okay. So two things. One, SSL is just that lock showing up. That's about all the validation is being performed. The other thing is that not only did we hijack the DNS, but our browser will load, we can trick the user into thinking that, any web app or any location is any other location. And it could be a phishing site just like your bank and other stuff like that. The funny part about this is that the browser still sends a host header of the site that's in your URL bar. So right now the browser is doing HTTP or it's doing get / whatever host blackhat.com for the IP of MI5. And you're thinking, why did we choose MI5? Well, we tried to do DEF CON. And they actually validate the host header and they throw a weird error and say that this Akamai instance can't be accessed or something like that. Then we tried, all right, well, let's do somebody else that would be kind of clever. Let's do, let's do the CIA.gov. And that validates it. And then we tried doing a bunch of other stuff. And then we landed on MI5. Oh, maybe they work. And so they actually don't validate the host header, which isn't really a bug at all, but it was funny for this. So how do we pivot? So essentially what we did in the browser is we load the file system API. We write to resolve.conf and we just write our name server that we want. So the Open Common File API, there's a directory traversal there. Oops, looks like that. So, DNS is cool, but some of the other APIs are even better. We've got external widgets, we've got network, we've got file system, we've got, player. So we've got control over the browser and we can load APIs and do things. What else? Well, let's pop the calculator because, that's awesome. But the TV doesn't have a calculator. So we did the next thing. We've got the camera. So let's see about that. So real quick, we made this little demo site, and it might not show up some with contrast, but essentially, you could scroll down and pick an attack and hit it, and it would run. And I actually reshot this video about 2 hours ago because we realized that the video that we brought from San Francisco was the wrong video, and it wasn't really work for this demo very well. So we just reshot this with the demo TV that we have for DEF CON Kids next on tomorrow, and we shot it and caught a friend of mine. He was just looking at the TV, and we said, "Oh, click that on." So he's going to kind of freak out real quick and bounce out. So that's the web browser, and I'll play it again. That's the web browser, and then you can see us doing our attack here. And then here there's the image of the camera, a video of the camera inside the browser. And what's funny about that is that it's actually not inside the browser; it's actually behind the browser. Because of the way the layering system works, and because we've hijacked an application, the camera actually shows up behind the browser. So we had about 2 or 3 days of fighting it and trying to use the legitimate APIs in order to send the browser to the back or send the camera to the front. And we really couldn't figure out how to make that happen efficiently. And so what we ended up doing was repurposing the picture-in-picture code for the browser and actually moving that to be the exact image of where the screen or the camera is displaying, because it's actually displaying behind the browser. And we kept seeing that happening where we would do the camera API attack, we wouldn't see anything at all, we'd quit the browser, the camera API would show up for 2 seconds and then die. And so by using the picture-in-picture code, we were able to hijack that, resize it, and move it in the right location to actually draw a transparent X window in the browser's DOM essentially, and then make it so that we can see the camera actually behind. And we can access this camera, but we also can, we could stream this remotely with a bit more work, or take pictures and upload those with a bit more work. So I have to speed up a little bit here. But essentially, Josh talked about this earlier, but we have this persistence. We can attack other apps. We can attack apps remotely. So this leads us to the idea of, could I just make an application virus that spreads all the other apps, and then when those apps run, they do things? And so we can write to arbitrary files, and applications are stored in a writable directory. So what we do is we just write to those files and include the code that we want. So I have a very quick demo here of an app that I hooked. Oops. And essentially what you'll see is this Viki app runs, and you'll see a little thing pop up there. As soon as I hit run on that bottom part, which is really hard to see, sorry, that little thing, right? It's going to pop up. As soon as I click run on the app, on the bottom there, you'll see it indent. And what it's really doing is it's downloading a remote JavaScript file and including it in the app. And so it happens before the app even runs. Thanks, Viki. So really some recommendations for manufacturers. Obviously, cross-platform security, doing web apps, you've got to have, having web applications, you're going to have those web application flaws. And really, think about how smartphones and how they handle security and start thinking about that. For developers, filter your input. Just like another web app, you have those same kind of problems. Don't really trust the storage because things can be read. As for consumers, obviously apply your updates just like any other device. Consider where you have the TV aimed. Maybe your bed is not the best option. Browse carefully and invest in sticky notes to stick over the camera. A very personal note on jailbreaking. So, obviously jailbreaking indicates that there's a vulnerability, and I believe, and Josh believe that jailbreaking really should be allowed by law. I should be able to go into a special option in my TV and say enable root and be able to do things that I want. It's something that I bought, and I want to be able to do what I want with it, right? And the EFF has a huge effort in DMCA exemptions for jailbreaking phones. But the problem is that the more and more smart devices that come out, the more and more that phone exemption for jailbreaking doesn't exist. So we can't just start plugging in remote phone. I can't start plugging in a cell connection to my TV and turn that into a phone. And so thanks for that. These attacks were not that difficult to find. They were fairly difficult to exploit, and that's kind of a difference there. DEF CON kids, we're going to be speaking tomorrow and having, definitely with different slides, but we're going to be speaking about, showing them about some basics of how the applications are written and a little about finding bugs. Because both Samsung and Facebook, which is the app we're going to be looking at, both of those companies have bug bounties. So we're going to have the kids find some bugs and then submit those to the bug bounties and get some money for school and maybe some money for the EFF. And the big takeaway is that using any of the apps, if they have some injection, and a lot of them do, you can really take remote control of the TV. And that, as Snyder says, attacks only get better. So as far as the future goes, there's going to be more and more HTML5 apps. And it may not even be TVs. It might be the next smartphone or, the next OS. And essentially, there was this article by Forbes that came out that said, there's going to be, 90 million smart TVs sold in 2013. And all the different major manufacturers are going to be adding, they want to be able to have their app work on multiple different platforms. So they'll just write it in HTML and JavaScript and everything will be cool. So big thanks to BlackHat again for having us. Big thanks to Mike Ryan for helping with some of the initial idea brainstorming and research. Big thanks to David for helping with our responsible disclosure. Big thanks to Nico and Samsung for working with us on these issues and having some calls and all of that. And then big thanks as well to SamiGo Wiki and their excellent work. So that's it.